the universe. So dark, mysterious, and unimaginably vast. Well, what if there was something even bigger? What if our entire universe was inside an unimaginably gigantic black hole? Here's the deal with the universe. It's so humongous that we can't see it all from Earth. So scientists observe what we can see and then make educated theories. A lot of times there's just no way to know for sure. Today, we'll explore how the universe formed and how it might die, how it could have formed inside a black hole, and what would that black hole do to you? Everything we think we know about our universe might be wrong. Now, we do know some things about black holes. First of all, that they come in a variety of sizes. We just haven't found one big enough to hold the entire universe. These light-consuming monstrosities have been around since, well, as long as the universe itself. Yeah, I'm talking about primordial black holes. We haven't seen one, but scientists theorize that in the first few seconds of the universe's existence, pockets of super dense plasma collapsed and created tiny black holes. Well, not all of them were tiny. Some could have been tens of thousands of times more massive than the sun. Maybe one of these swallowed our young universe, and together we kept growing. Okay, we'll get back to the different black hole sizes in a minute. Right now, you're in the middle of the hottest time in the history of the universe, the Big Bang. I'm guessing you're pretty familiar with the Big Bang Theory? Math, science, history, unraveling the mysteries? No, not the TV show, the actual theory. It all happened 13.7 billion years ago. Back then, every atom, material, and molecule in the universe was packed into an infinitely tiny and extremely hot singularity. Then, suddenly, a big bang. Everything expands and comes charging outward at the speed of light. In a fraction of a second, everything needed for complex galaxies to form is spilled out into this infinite space. But here's a problem. If our universe is really inside a black hole, well, then the Big Bang Theory is wrong. Because black holes don't expand things inside of them. Black holes compress. Okay, so scientists agree that the Big Bang is likely how the universe was born, but the universe being inside a black hole doesn't fit with what we know about the Big Bang. So, are we wrong about the universe? Where does this universe inside a black hole idea even come from? Well, I'll tell you, but buckle up, Buttercup, it's science time. Recently, a very curious science paper was published, and it made scientists doubt what we thought we knew about the universe. I'll try to break it down. The researcher looked out at our sky very closely with the James Webb Space Telescope and noticed something strange. About 2/3 of the spiral galaxies in a region of the sky appeared to rotate clockwise, while the other third of the spiral galaxies in that region rotate counterclockwise. Now, what's strange about that? Well, it's unexpected because the Big Bang Theory relies on something called the cosmological principle. It's the idea that on a large scale, the universe looks the same in every direction and in every place. That means that galaxies should be spread out evenly and their spins should be randomly oriented with no overall pattern. Turns out, they're not. And if we start to see more galaxies spinning one way rather than the other across large parts of the sky, that could be a sign that the universe isn't as uniform as we thought. And that would be a serious challenge to the foundation of modern cosmology. Still with me? Good. Well, you know what else is known to rotate? Black holes. Maybe being inside of one messes with the rotations in the universe. Now, here's something that'll really mess with your head. Take all the mass and energy in the observable universe and plug it into the formula for a black hole's event horizon. In that case, you get something pretty close to the actual size of the observable universe. Yeah, in other words, if the universe was inside a black hole, its radius would be about the same as the distance we can see in every direction. Maybe that's just a weird coincidence, but some scientists think it could be a clue. Maybe the reason we can't see beyond the edge of the observable universe isn't just because of light travel limits. Maybe it's because that edge is the event horizon of a black hole. Not one that's sitting out in space, but one that we are inside of. Think about that next time you look up at the stars. More importantly, how does being inside a gigantic black hole affect you? Well, I may have overplayed the way your life would change, other than the fact that you might be living inside an actual bigger-than-the-universe black hole, which is pretty cool. Day to day, your life would be the same. But how would our universe ever have come to exist inside of a black hole? And does that mean our home black hole is inside another universe? And are the black holes in our universe also homes to other universes? Okay, I did the thing where I said universe too many times and now it's lost all meaning. Universe. Anyways, getting back on track. If our universe is inside a black hole, we'd really have to rethink how the universe began in the first place. The Big Bang Theory? Well, it could still describe how our universe started expanding and how galaxies formed, but instead of being the absolute beginning of everything, it might have been just the moment a black hole in some larger parent universe created a new, sealed-off pocket of space-time, our space-time. So, all the stuff the Big Bang model explains still works, it's just plugged into a much bigger story. Now, instead of the Big Bang, it could be the Big Bounce. That's the idea that our universe didn't start as a hot and dense singularity. Instead, it started when the previous universe collapsed. Now, our universe could have expanded and contracted so many times in its history. It could be much, much older than we suspect. The Big Bounce doesn't have to happen inside a black hole, but it could. Now, what type of black hole would that be? Well, in the beginning of this video, I mentioned primordial black holes, but even at their largest possible size, they're not big enough to hold the entire observable universe inside. So let's quickly check out some of the other types of black holes, starting with the stellar mass black holes. As the name suggests, these black holes form when a massive star collapses in on itself. The star has to be at least 8 times more massive than the sun, so don't worry about this happening here. You won't ever see our sun become a black hole, although the view could be pretty sweet. These stellar black holes are everywhere in the universe, but even though they sound massive, they aren't all that large. Stellar black holes are extraordinarily compact. For example, if Earth suddenly collapsed to become a stellar black hole, it would have a radius of about 1 centimeter. It's about the size of your belly button. So, yeah, these black holes definitely wouldn't be large enough to hold our entire universe. But intermediate mass black holes? Let's see. These black holes might sound mediocre, but, well, they actually are. For a black hole, I mean. But they're still impressive, and they have a mass anywhere from 100 to 1 million suns. Still, not big enough to fit the entire universe. But supermassive black holes, now we're talking. These are as massive as at least 1 million suns, and we don't even know how they formed. If we are inside a black hole, it would definitely be a supermassive black hole, right? Wrong. Even though they are unimaginably massive, supermassive black holes are still only astronomically large. They're not cosmologically large. Remember that black holes are unimaginably dense. Even a supermassive black hole that's 10 billion times the mass of our sun would only be about 200 astronomical units across. That's about the same diameter as our solar system, if we include the Oort cloud. No, the black hole that could fit the universe would have to be stupendously large. And I didn't make that up. That's the actual name for these black holes. Stupendously large black holes, or slabs. Well, for now, slabs are hypothetical. We haven't seen one yet. Scientists think that if they do exist, they're extremely rare, or that they exist in unusual environments, like outside of our universe. We might never know. And while we're speculating on what kind of black hole might have swallowed our universe, that black hole could be preparing to end it. Yeah, did you think living inside a black hole would just be a cool fact you could bring up at parties? No. Black holes are dangerous and hungry. If somehow you were to approach a black hole and you got too close, you'd get spaghettified and die a horrible death. Chase, our space correspondent, knows something about dying in a black hole.
Oh God! I don't think they're supposed to stretch like that!
Anyway, we might be inside a black hole, and it might end the universe. Look, there are a lot of theories on how the entire universe might finally end. One popular one is called the Big Crunch. Yeah, it sounds like a delicious sandwich option at an Italian deli or at a KFC. But what it unfortunately means is that the entire universe goes... The idea is that right now, the universe is still expanding from our initial Big Bang singularity, but eventually it'll stop expanding, and when it does, all that mass will have such a strong gravitational pull that everything will begin to contract. The universe will shrink, and everything inside it will collapse. Planets will collide, asteroids will have a much higher hit rate, black holes will swallow more and more galaxies. It'll be chaotic. Everything will be destroying everything else until we return to being an insanely hot, dense singularity, similar to the one that started the Big Bang. Or until everything collapses in on itself and forms a monster-sized black hole. So we'd have a black hole inside a black hole, which sounds a bit Inception-y. But these two black holes would just merge into one, even more stupendous black hole. So yeah, it would kill everything you know, but the good news is that the contraction would take as long as the expansion. The universe has been expanding for billions of years, so even if the contraction started today, we'd still have a ton of time. Well, the gravitational forces of the black hole moving inwards might accelerate that a touch. The Big Crunch fits nicely into another theory we've talked about, the Big Bounce. In the Big Bounce theory, the universe doesn't just compress all the way into a singularity. It also expands again in a totally new Big Bang. But this theory doesn't make sense if we really are living inside a black hole. Remember how I said black holes don't expand things inside of them, but rather contract everything. Now imagine throwing a ball against a pit of goo. That ball is not bouncing back. Okay, that wasn't a perfect analogy, but there really isn't anything on Earth comparable to a black hole. And if there were, I wouldn't be making this video and you wouldn't be watching it. We'd both be getting spaghettified. Well, maybe the inward force of a black hole is so strong that it requires some kind of huge cataclysmic explosion for anything to expand. Yeah, there's still some things scientists need to think over for all of this to make sense inside a black hole. So, let's just say the big bounce is cancelled and the universe is somehow set to expand forever and ever for all eternity. Well, that's not happening because there's another theory for the end of everything. It's called the Big Freeze. In this model, the universe reaches a point of maximum entropy. That's the state where the universe has expanded so much and distributed all its energy so evenly that nothing interesting is happening anymore. The universe will slowly become so dark and so cold that no life can emerge on any planet in any galaxy. It'll all come to a standstill. The only entities left in the universe will be black holes, but even those eventually decay. If we were inside a black hole, the universe's expansion is a tough one to explain. Like I said, black holes like keeping things densely packed. If the Big Freeze is how it all ends, well, I don't see how that could happen inside a black hole. All these theories are built on different assumptions about observations of the universe. Right now, it's impossible to know which assumptions are true, which makes everything possible. Even an extremely violent end. The Big Rip, which, excuse my language, sounds like a fart. Seriously, science needs to revisit its naming conventions. Okay, so the Big Rip is the kind of end where the universe keeps expanding faster and faster, thanks to mysterious dark energy. Now, we don't know what dark energy is, but we do know it's there because galaxies are moving away from each other faster than they should if gravity were the only force at play. It's like there's an invisible pressure pushing everything apart. Eventually, any 2 points in space would be torn apart faster than the speed of light. At this speed, the laws of physics no longer apply, and we enter a rate of expansion that causes complete chaos and destruction. On the off chance humanity is still alive at that point, you'd probably be vaporized in less than a second. You wouldn't even have enough time to register the pain before you ceased to exist. If this elusive dark energy does overcome the forces of a black hole, well, then the Big Rip could still happen inside of it. So, yeah, the most violent option is still viable if we lived inside a black hole. Alright, there's one last doomsday possibility. It's called the Big Slurp. Are you kidding me? Okay, I thought the Big Freeze was going to be the most slushy sounding one, but no, there's also the Big Slurp, more well known scientifically as vacuum decay. Now, our universe is not a true vacuum. It's almost a vacuum, but there are still particles and magnetic fields in all areas of space. If there were to be some kind of high energy event out in space, well, this may cause an area of the universe to go from a false vacuum to a true vacuum, and that would be catastrophic. What starts as a small vacuum bubble would rapidly expand in all directions and at the speed of light and tear up the entire universe. But vacuums existing inside a black hole would be pretty unlikely, given that black holes are constantly taking in matter. So, again, that theory would be pretty irrelevant if our universe were inside a black hole. If we are inside a black hole, well, that black hole could be part of another universe, and that universe has other black holes that could have universes, and in those universes, well, more black holes with more universes. Even if we're not inside one, our universe has black holes that might be home to others. Okay, I did the thing where I said the universe too many times and now it's lost all meaning. tartlets. Tartlets. The point is, the idea is like an infinite cosmic nesting doll. Every time you think you've reached the end, look again, there's another. And in this multiverse system, each of these universes could have their own laws of physics. Like, maybe in one universe, large mass has a repelling effect, so gravity works in the opposite direction, and everyone's getting flung out into space all the time. Or maybe pushing something away makes it move toward you. These may sound absurd, but there's just no way of knowing the way different universes have been warped.
Oh god! I don't think they're supposed to stretch like that! This is what Rico thinks is gonna happen to me when I jump into a black hole? Okay. I'm thinking that this is one of them wormhole-y black holes that's, gonna take me to another parallel universe or something instead of rip me to shreds.
I didn't say it would rip you to shreds. I said it would spaghettify you. Spaghettification is the process of being stretched by immense gravity until you're reduced to a thin stream of matter.
That doesn't sound any better. Besides, I'm more of a fusilli guy. But if that's what it takes for you guys to subscribe to my channel, I'll do it. Subscribe.
You are coming off as desperate.
Yeah, whatever, alright. I'm about to jump into this black hole for just 1 nanosecond. Can I travel to a parallel universe before I get pulled back out?
You never said anything about pulling you out. That would be impossible.
What?
The black hole's gravity pulls so hard that no amount of force is able to pull you out.
Rico!
You'll be stuck moving toward the center, no matter what.
Oh, come on! Oh man, I'm not starting.
I'm starting to not feel so good.
You're starting to move in slow motion, even if time still feels normal to you. This is because the strong gravitational field near the black hole slows down time relative to an observer far away, a concept known as time dilation.
That's not how Nolan did it in Interstellar.
Yes! I told you that would work, Rico! Never doubt your boy Chase! Oh. Just like I suspected, the black hole was actually a tunnel through space-time, a wormhole, as the science nerds call it. And the other end has dropped me into a parallel universe, instead of crushing me like Rico said it would. I'm a genius.
Don't celebrate too much yet.
Huh? Oh, for fuck's sake! Even in a parallel universe, everything's out to kill me.
This isn't the universe where you survive at the end of every episode.
Wait, what? You mean that exists?
No, that's not what I meant.
Oh, well, of course! Why didn't I think of that? Theoretically, there are countless parallel universes where every possible outcome of every event happens. So all I need to do is keep jumping from universe to universe until I find one where I don't die at the end of every episode.
We're in purely speculative territory now. It can't be that simple.
Watch me, Rico.
Maybe I can find a universe where I don't die, and my YouTube channel is hugely popular.
Oh, hey, that's looking better. Yeah, that's not happening. Let's try again. Hello? Are you guys real? I didn't sign up for this! Huh?
You see that vicious jealousy in chimpanzees. One of the things they attack people over is
Okay. This is getting weird. Alright. Huh. Everything seems pretty normal. Huh. Huh. I'm gonna bust into this hospital and steal all the real. That was a sick way. Yo, what up? It's your boy Chase. Hey, what's up, broskies? So today, I'm gonna be doing the train prank, where I'm gonna set up 400 mannequins, and we're gonna see which one of us gets hit by the train first. It's gonna be epic. Holy crap! Rico! It's me! It's me! Oh. Hey, what's up, broskies? So today, I'm gonna be doing. Oh man, is that what I look like?
Yes, he is an exact match. Except he has 5% less body fat, 13% more symmetrical facial features.
Yeah, okay, I get it. Thank you very much for being very explicit. What's going on? After I get bolted into space by this train, we'll see if I survive. Probably land on the moon. I'll probably land on the moon, or maybe I'll end up in orbit. I love you! I love you guys too! Yeah, totally! Oh, let's take a photo. Yeah. No, I'd love to do more selfies. Okay, don't touch me there. Alright, chill. Yo, Chase heads, chill! What are those things?
Subscribers.
Huh?
He has 500 million of them.
What? Hey, what up, dudes? That was totally a prank! I'm still chilling. Hey.
Catchphrase!
What am I watching here? It's a prank! I'm just kidding, you idiots! Why are you all screaming?
Bro?
That's different. Bro? Hey, wait! Wait for me! Rico said, you can't jump into a black hole, and I was like, listen up, Rico boy. Chase here can definitely jump into this black hole. So that's what I did. I jumped in and spaghettified, fusillied myself all the way here. And somewhere between all this, I was on Joe Rogan, somebody wanted me to eat a bunch of hot dogs, and now I'm here. So, no matter what sick tech or rad gear you roll in with, you still totally bite it at the end of every episode? That's what you took away from this? I mean, I know it's lame, but no, bro, that's epic. I mean, you might bite it at the end of every episode, but at least you come back, smelling minty fresh as ever. Me? I just never die, no matter how wrecked or busted up I get. But you're living the dream. You've got your face on billboards. You've got mobs of crazy fans who love you or want to eat you. I'm not really sure what was happening over there, but it seemed cool. Bro, they're crazy. Like, they keep pushing me for gnarlier and crazier stunts. Now they've got my sponsor, Red Bull. Red Bull gives you wings. Hopped up on this massive live stream. I don't think my body's gonna come out in one piece, bro. Dude. They want you to go into that? Yeah, and I mean, like, I want to, and like, my agent's saying that it could slide me into more science-y videos, and that's where the big bucks are, man. But dude, if I go in there, I know I'll be stuck in there forever, just getting stretched for all eternity. I'm no superhero, not like you, bro. I'm no superhero. Where am I? I've got an idea. I'm gonna get in your pants. What? Bro, I don't think anyone's gonna believe that's me. That suit's way too tight. You can barely move, bro.
That's because he has 5% more body fat than you.
Yes, you had mentioned that already. Thank you, Rico. Wait, did you build this spacecraft? Yeah, bro. Why? Yeah, that's not gonna cut it. Cue the montage. Right now. Start it! Okay, so, if you flew a regular old spaceship into a black hole, it'd be a pretty short live stream. The gravity pulling on the part of the ship closest to the black hole is much stronger than the gravity pulling on the back of the ship. So, it'd be ripped in half long before you reach the center of the black hole. You'd also be bombarded from the intense amounts of radiation escaping from the hole, which would not only disable the spaceship's systems, but also melt your face off. Luckily, the spaceship I've built for you can withstand all that, but the technology required to do so is too complex for puny human brains to understand, so it won't actually be you flying the ship. It'll be me, dressed as you. You just wait here until I go into the black hole. And then you reemerge, with everyone thinking you just pulled off the most amazing feat in the history of the universe! Even though it was me, and I've technically done it a few times now. And then you'll have all the credibility you need to start that science channel you've always wanted. You really think you can fool all my fans, bro? Yeah, bro, I think I got it, dude! I might need a new suit, though. What's up, yars? It's your boy Chase, still alive! Oh, thanks, Slim Jimmy. You're my bro from another mother.
You might want to tone it down a bit. Besides, you still have time to change your mind. I thought this universe was everything you wanted.
Yeah, I think I'd rather have my small group of real supporters than these 500 million monsters. I miss you guys. You're the best, really. Remember when we went to the moon and I made that hamburger that you guys watched me choke to death on? You guys were there with me every step of the way. Plus, I'm starting to think that my dying thing is some kind of superpower. Should I get a suit? Like a super suit?
Wow, that really went to your head.
I don't know what you mean. Here we go, bros! Grab your Red Bulls and crush them on your face in 2, 1! Wah! Whoa, bros! Did it work? Rico, do you see the other chase anywhere? Wait. How did we end up right back where we started?
What are you talking about?
The parallel universes, the other chase, the live stream, the Joe Rogan experience. You don't remember any of this?
No. As soon as you entered the black hole, you were immediately spaghettified to death. And now, you are here.
No, there's no way I imagined all that. Rico, check your hard drives or something. We traveled several very different universes. We jumped in like 5 black holes.
The concept of traveling to a parallel universe through a black hole is extremely unlikely. Even if it was possible, the odds of you passing through the event horizon before dying are very, 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 very low.
But not impossible for someone with superpowers.
It's a 3-dimensional hole, and one of my gripes that I have sometimes with how these sorts of things are portrayed in movies and stuff is they tend to think of it as like a circle, and then you sort of fall in and you go somewhere. But where it's more of a sphere, you can approach it from many different directions. So the other side is sort of a weird thing to think about, because you don't mean, I think, the other side so much as you mean the other place it may go to.
So, Pete, how are you?
Welcome to the show.
Yes.
I'm very well. Every week I'm the same, really.
Yeah, I know. I should start differently.
Yeah.
Okay, I'll start differently.
Okay, so
how are your eyes?
My eyes. Just like the year, 2020.
Whoa, ladies and gentlemen, Peter Smeechin dropping the comedy. I would say, unfortunately, that my eyes are also like the year 2020, getting worse. It seems every month, as people at home can tell, I do wear glasses. Right. I'm nearsighted. You can see very well, and always have been able to, right?
I can see a lot of things. I can see everything far away.
Yeah.
I can see through a lot of things, like your cheesy openings. But one thing I can't see through.
Yes.
What do you think?
Black holes.
Exactly.
Well, I mean, by definition, very difficult to see through, right? Black. They're large. They're, it's a massive mass that really, I think, only theoretically people believe we could see through. But again, all due respect to you, all due respect to me, we're not the people who are going to be able to answer that question. So that's why we have experts on the show. And today we do have an expert from the University of Southern California, a professor from the physics and astronomy department. You know him, you love him. He's a friend of the show, Professor Clifford Johnson.
Welcome back.
Welcome back to What If Discussed.
Hi, how are you?
Good.
Well, we're good. We're kind of debating. I don't know if we're debating, but we're trying to figure out.
You'd know if I was debating.
Could you see through a black hole? And obviously, this is theoretical. So, this is the time to be a theoretical physicist. Let's start with Ken. What would you see if you looked into a black hole?
That's a great question. So, to a first approximation, in my physicist way of saying things, you wouldn't see anything coming from the inside, because in some ways, by definition, at least in classical physics, the black hole is not letting anything escape from it. Now, one of the things people think about a lot in recent times has been black holes, say when you combine them with quantum physics, because when quantum physics is included, there is some sort of mechanism which goes back to Stephen Hawking, who you may have heard of, right? Who said and showed that when you combine quantum physics with black holes, there's a sense in which they radiate stuff out. And there's a way of thinking about it that means that in some sense the stuff is coming out, energy is coming out from the black hole. It's losing energy. Now, one perspective says it's just some quantum stuff happening near the horizon and it comes out and it isn't really coming from the inside. But another perspective says that in some sense it is telling you stuff about the inside of a black hole. So people are very excited about trying to understand the full quantum story of a black hole, because it tells you essentially about the fate of the black hole, the fate of what fell in ultimately. That stuff all has to come out in this process by which the black hole evaporates, if that is a real thing. Now, I should say that black holes that we see in astrophysics, made from collapsed stars or even larger, their evaporation time and the evaporation effects of the quantum physics are essentially negligible. It would take so long to lose any significant amount of energy that you'd wait longer than the lifetime of the universe. So this is very much in the realm of what if in the theoretical physics world, where you're thinking about the fate of perhaps small black holes if they were to be discovered.
I love that you use the term "what if." It's very rare that we get a guest.
Snuck in a plug.
It's the show "What If." So that kind of covers what we would see, what might be in a black hole and what might be emanating from a black hole. But if we take this visionary theoretical journey right to its conclusion, what would we see on the other side of a black hole?
Oh, well, that's an interesting question. Part of the question would then be, I would have to go, well, what do you mean by the other side? If you think of it as...
Is there another side?
Yes.
It's a three-dimensional hole, right? And one of my gripes that I have sometimes with how these sorts of things are portrayed in movies and stuff is... They tend to think of it as like a circle, and then you sort of fall in and you go somewhere. But where it's more of a sphere, you can approach it from many different directions, and you'd go in. So the other side is sort of a weird thing to think about, because you don't mean, I think, the other side so much as you mean the other place it may go to. And so you could imagine that there's another spherical object somewhere else, which is like the other end of that hole, and you would then emerge coming out of that, and that would be like the exit. Does that make sense?
Oh, wow.
Like a wormhole type thing?
Well, those are among the things that people have speculated about, and you can find solutions of the equations of relativity, which is where we study black holes, that give you those scenarios. But the plumbing is higher dimensional than we normally think of, right? You think, for example, of like a garden hose, right? It has one end, and that's essentially a circle, a disc that you go into, and then you come out the other end. Instead, you would have a whole sphere, which is like a higher dimensional circle, and then you come out a sphere somewhere else if you were to engineer a wormhole. As far as we know, that's fraught with physics difficulty. Real stable wormholes are not thought to be possible as far as we understand, but it's fun to think about them. And of course, we use them in science fiction a lot.
Yeah.
And Einstein left the door open for that, didn't he?
Well, he not only left the door open, he helped discover the door, right? The original wormhole solution was discovered by Einstein and Rosen, and there was a paper where they actually pointed out that you could, by examining the geometry of the standard black hole solution that is used to study real astrophysical black holes, you can actually see that it contains the possibility of indeed going what seems to be into the black hole and then coming out another side, and it's like you're like exiting from a different black hole, or it's the same black hole, up to you how you think about it. And that was the wormhole solution, otherwise known as the Einstein-Rosen bridge, bridge between two different sort of regions. But as they already observed, you'd have to do things like move faster than the speed of light to traverse that wormhole before it collapsed.
Few nuts to crack.
They tend to collapse before you can do anything with them.
If anybody's seen the opening or seen the show Raised by Wolves on HBO Max, I believe, but the opening has them essentially doing exactly what you just described, going through, popping out another sphere. Worth checking out. You can watch, I believe it's that just the opening is on YouTube. It's worth checking out. It's kind of an illustrative vision of that theoretical idea. Theoretical being sort of the key word when we're talking about big what ifs, especially something like black holes and looking through them. But is it possible that these things will be a little less theoretical and a little more concrete as we develop new technology? I know that there's the Event Horizon telescope and the Virgo cluster. You know, there's other bigger telescopes. Do you anticipate we're going to be able to learn a lot more from these new eyes on these black holes?
Well, the Event Horizon telescope is a wonderful example, as you say, of what you can do with new technology. And it's, in some ways, it's new technology combined with old technology in the following sense. What the Event Horizon telescope is, it's actually a network of existing telescopes, and new ones being built will be added. It's a network of telescopes all around the Earth that you connect together by, so you're getting them all to look in the same direction at the same object. And so that essentially gives you one massive telescope the size of the Earth, which is what you need in order to see something very far away in great detail. And the technological aspect there is that you need to somehow combine all that information from all those different telescopes in the right way with amazing computer technology, amazing collaboration by hundreds of scientists. And they collaborate in order to combine these data using modern algorithms and super fast computers to do that, and then essentially turns it into one giant telescope. So indeed, the landmark thing that you probably all saw in the news, what was it, last year? I think it was last year, right? That first image of the black hole event horizon, which I remind you, because people often miss this fact, it's the first time we're seeing, in any extended sense of the word seeing, a black hole, or at least the event horizon, the shadow of the black hole against the stuff that's glowing around it. Every other image you've ever seen depicting a black hole has been an artist's impression. It's easy to forget that, because you see these wonderful artist impressions of matter coming off one star and falling into a black hole. It looks super realistic. An artist did that. Except in this case, this really is real data turned into what it would look like. And so we're going to learn a lot more about black holes that way. And I think, whether or not the business of whether you can see into it and see out the other side or what have you, which is probably going to remain speculative in some sense, we're going to learn a lot about the black holes themselves and how they dominate the physics in the core of our galaxy, how they interact with the stuff there, how different galaxies, black holes are different from each other as we start imaging other black holes. It's going to be huge, the amount of stuff we're going to learn from that. And it is awesome that we're really looking at the shadow of a black hole with our own eyes for the first time in our history, in our civilization's history.
Spectacular.
Super cool. Crazy times.
Professor, thanks very much for taking us through this speculative vision quest. Where can people go to find your work?
Well, it's probably easiest to find me on either Instagram or Twitter or Facebook by just Google my name and physics, Clifford Johnson Physics. That's the easiest way, rather than trying to figure out what.
Yeah, and that's I would also. Sorry, go on. I was just going to say that's what I did, and it brought me down the whole Clifford Johnson rabbit hole too. So to your point, it's the best place to start. Clifford Johnson Physics, maybe USC as well.
Yeah, and you'll find, like I said, lots of thoughts, discussions on my blog, images I share of physics ideas or other things, other activities I get up to. And you'll find your way maybe also to my nonfiction graphic book about the nature of the universe, which I wrote and drew a couple of years ago, published by MIT Press. There's a lot of ideas in there about space and time and quantum physics, a little bit about black holes and how you can use them as time machines, for example, and things like that.
Thank you, Professor Johnson. In quantum physics, there's something called the observer effect, which is very interesting in that literally what you see and what I see of the same thing might be different.
Ooh.
So when you apply it to especially things as theoretical as black holes, when we're asking, what would you see if you saw through a black hole? Well, of course, beauty is in the eye of the beholder, as they say. Who knows what you're going to see? But at least when you talk to somebody like Professor Johnson, you at least get a better guidance system on what you'd be looking for, because here I'm asking that question in a two-dimensional sense. And I hadn't even thought that, of course, that's idiotic.
Yeah, they say there's no dumb questions, but maybe that was
Yes.
the dumb question. Yeah, no, I always thought too that black hole is just it's a hole.
Yes.
And you fall into it.
Idiotic.
Not realizing it's spherical or it's three-dimensional.
Yes.
Of course, it's not a black hole, it's a black orb.
Yes, exactly.
Really,
And he
yeah.
sort of helped us understand that and helped us understand a few other things.
Right. Well, we'll be seeing more black holes, not coming up anytime soon, but as our technology gets stronger, as we send Hubble or Webb telescopes into space and get a better look and usher in basically a new era of space exploration. And we'll also explore a little bit more with Professor Johnson on the extended audio podcast. Now, if you're watching us and you want to hear more, well, just click on the link below and you can join the extended audio podcast. If you are already listening to the audio podcast, don't worry, there's nothing to click on. Just keep listening. We'll be with you in just a second. Now, if you are watching on video and you're leaving us, well, thanks for joining us. We'll see you next week on another What If Discussed. This podcast is brought to you by Bespoke Post's Box of Awesome.
Everything you can imagine doing in the vicinity of our sun, for example, like having various objects in orbit around it, essentially, for billions of years. You could do that with a black hole as well. Just because the black hole is there doesn't mean that it's some big vacuum cleaner that sucks things in.
Pete, I know you know a little bit about black holes.
I do, because on What If, every eighth
Third
story,
video?
sometimes it seems like every third video. Yeah, we do a lot of black hole videos here.
But that speaks to the fact that tons of people are fascinated with black holes.
It's a fascinating subject because most people know nothing about them other than they're a black hole that sucks stuff into them.
And as we'll find out in today's show, there's going to be some myths and misconceptions about black holes that will be answered, because a lot of the things we think we do know are starting to change. But that's why we have guests like physics professors on the show to be able to help us sort out things like, what if our solar system orbited a black hole? Today, we're going to be joined by USC professor of physics, Clifford Johnson. So let's get started. And again, like we talked about off the top, black holes, you and I, superficial knowledge at best. Again, that's why we like to have experts on the show to help us understand, in this case, what if our solar system orbited a black hole? I don't really know the answer.
Would we get sucked in?
Pretty sure you don't know the answer. So we're joined by, again, Professor of Physics from the University of Southern California, Clifford Johnson.
Hi, great to be here.
Professor, thanks for joining us. It sounds like a simple question to start, but we might as well go there. What is a black hole?
Well, that is something that does come into various of these fields in a way, because we think about the nature of space and time, and a black hole is fundamentally something very, very fundamentally different about space and time that we had thought of, that had been thought of until the last century of work in great detail. And what it is, we understand in general, is simply a region of space where, for whatever reason, the gravitational pull is so strong that not even light can escape from it. In the sense that, if we wanted to get off this body here, Earth, we send rockets away into space, and we do that by getting up to a certain speed, a certain escape velocity, which allows you to escape the gravitational pull. And for reasons that we could go into, but let's not for now, there's a fastest possible speed that you can do in this universe, and it's the speed of light. So if you had a body that was so gravitationally strong that the escape speed was faster than the speed of light, then nothing would be able to escape from it. And that's what a black hole is.
There's various levels of black hole, as I understand it. It's kind of like the Wendy's drive-thru. There's your regular black hole, and there's your supermassive black hole.
There's a medium, a triple, a double.
What's the difference between a regular and a supermassive black hole?
Well, one of the amazing things about black holes is that they are, by some definitions, very, very complicated objects. And by other definitions, they are the simplest objects in the universe that we've ever encountered in physics. And so in some ways, the only difference between those different kinds of black holes that you talk about is how big they are. And so you have black holes that have roughly a few times the mass of our sun, because they come from stars that have, in some sense, died. They've gone to a new phase of existence where they're no longer glowing like stars, and they collapse and they form this compact object. And so they have a mass that is essentially related to the stuff that collapsed. But then you have regions of space, for example, at the core of most galaxies, where there are black holes that are huge, hundreds of millions of times the mass of a typical star. And in some sense, they're very closely related to those smaller kinds of black holes. And they're also intermediate mass black holes. And some of us speculate that there may also be microscopic black holes as a possibility in nature as well.
All shapes and sizes.
Kids meal.
Yes, a kid's meal. One of the, I guess more recently it's being called a misconception or a myth about black holes. I know for the most part in the sci-fi world, it was always portrayed that you get sucked into a black hole. Basically, if you're, in too close proximity to a black hole, well, that was it. You couldn't help but get sucked in. That's not exactly true, is it?
Exactly right. Again, you should think of a black hole as, in many of its properties, it's very similar to any big blob of matter that you can have if you're far away enough from it. And so everything you can imagine doing in the vicinity of our sun, for example, like having various objects in orbit around it, essentially, for billions of years. You could do that with a black hole as well. Just because the black hole is there doesn't mean that it's some big vacuum cleaner that sucks things in, which is often portrayed that way and makes it feel like some kind of intentional behemoth. Yeah. No, they're just gravitating objects like anything else. And so you can be near a black hole for an arbitrarily long time. The issue then is what happens if you get to that point of closest approach, whereby you then didn't have enough engine power to escape, or even if you had all the engine power in the world, you couldn't get faster than the speed of light to get away. And that's called crossing the event horizon. And there is a point of closest approach, which you then wouldn't be able to, at least classically, and I could explain what that means, escape. But if you're not within the event horizon, in principle, you can approach and move away, and it doesn't suck you in.
Well, I guess the big what if for today is what if our solar system orbited a black hole? Is it possible? I think from what you're saying, it is possible for a planet or a solar system to orbit a black hole. But is it also possible for them to orbit a black hole and sustain life?
I would say my guess is probably yes. And I can imagine a number of different scenarios where that could come about. So, for example, let's first dispense with the issue of whether we think there may be other forms of life on other planets. Let's say that's not beyond the realm of possibility, and you've probably discussed that in other shows. So let's say that there are other stars for which there are other maybe Earth-like or maybe not Earth-like, but they have life. Now, it might be that star may have been part of a binary system, for example, where you have a double star, two stars orbiting each other, and then there are planets orbiting that system. You can imagine that sort of thing. And maybe one of those became a black hole. It might have been that it happened with some sort of cataclysmic explosion, as often happens, called a supernova explosion, a type 2 supernova explosion. That may well have obliterated all the life nearby, but let's say it didn't. Then that could actually be a rather unusual, from our perspective, but a home for that form of life. Or another possibility is that you have some starfaring species that intentionally seeks out a black hole and decides to settle around it. They either build an object which orbits it, or they occupy some planetary matter that is orbiting that black hole, and that becomes their star system. It turns out you can actually mine black holes for energy in a certain kind of way, and they would be among the most efficient sources of energy if you could do the kind of engineering you would need to exploit it. So maybe there are super advanced civilizations that are living around black holes.
Sorry, I was just going to say that literally sounds like Peter's wearing a t-shirt that says, "That's a story for another what if." Mining black holes for energy is exactly a story for another what if. That is so cool, and not something I think we've even heard about here, but we will explore it. Lots of mysteries around black holes and a lot of misconceptions about black holes. So thank you, Professor Johnson, for helping us clear some of those up. We're gonna have a longer conversation with Professor Johnson on the other side. Before we do, where's the best place for people to follow your work?
Oh gosh, I would say they could probably either find me through my blog or through Twitter or Facebook or Instagram. It's probably best just to Google me. My handle on those things is usually something called asymptotia, but telling you to spell that, it's easy if you just Google my name and physics, and you'll find me. And a nice compact way is to look at a graphic nonfiction book I wrote and drew a couple of years ago called The Dialogues, where actually I talk about some of these issues.
Great stuff, Professor Johnson. Not surprising, obviously. We always get to learn cool stuff here on What If Discussed.
That's what we're here for.
If you had asked me prior, do black holes suck things in like a vacuum cleaner, as he so eloquently put it, I would have said yes.
Yeah, that's what we've learned. That's what we've seen in movies and TV.
Got to be 10 episodes of Star Trek based on it.
Yeah.
But as it turns out, that mass, that incredible mass actually just creates gravity. Some people will say tomato, tomato, but I think it's a good clarification. What did you learn?
I learned that I was really impressed that you could mine a black hole. That sounds,
Super cool.
I mean, I haven't learned enough about that because I want to ask him that sort of stuff on the other side. So we will continue our discussion with Professor Johnson on the extended audio version of the podcast. So if you would like to join us for more, just click on the link below. If you're already listening on the audio podcast, there's nothing for you to click. Just stay with us. We'll be back with more Professor Johnson. Otherwise, thanks everyone for joining us on What If Discussed. A black hole is coming straight for Earth. We could wait for it to gobble us up, but instead, we're going to try to destroy it. We'll throw everything we can at this black hole, from nukes to advanced technology that we might not even have access to yet. Maybe we'll even try to throw a white hole at it. Is it even possible to destroy a black hole? You know what? Enough questions. We have a serious mission to accomplish, and if we don't, humanity will go extinct. This is What If, and here's what would happen if we destroyed a black hole. Okay, our first attempt at destroying this black hole will be to nuke it. We're going to collect every single nuke on Earth and launch them at this black hole that's speeding right toward us. This will produce energy equivalent to 425,000 times the atomic bombs of World War II. Now, we know that the destructive blast of a nuke decimates anything, so all these nukes should do the trick, right? Well, not so fast. Black holes are tricky because what they do is consume. Like some kind of super hungry space giant, they want to suck up all the matter and energy that they can get their grubby little cosmic hands on. But let's try launching our nukes anyway. As they enter the black hole, you sit and wait for the massive explosion that will destroy this celestial phenomenon. But instead of being destroyed, the black hole eats the nukes for a snack. And now, it's more massive than before. Ugh, great. Well, as the saying goes, that which doesn't kill a black hole only makes it stronger. Or something like that. Bullets, lasers, and ginormous super weapons won't work either. So, is humanity just expected to suffer the fate of being gobbled up by the black hole? No, you are not going to let the human race die out. But it's clear we have to try a more crafty strategy. One with artificial black holes, white holes, and maybe even a time machine? But before we get to that, let's figure out the basics. After all, as Sun Tzu said, know thy enemy. So, what makes a black hole tick? Black holes are these super dense areas in space, so dense and so gravitationally strong that not even light can escape them. And it's estimated that our Milky Way galaxy has 100 million of them. Now, a black hole can form in two different ways. One way is when a cloud of gas collapses. These types of black holes can be enormous, 1,000 to 100,000 times the mass of the sun. Then there's a second way. Stellar mass black holes form when a massive star explodes and dies, leaving behind a very dense core, which is the black hole. These are smaller, with masses just a few times that of our sun. Now, what happens when we get a little bit closer? Well, as you approach the mouth of the black hole, you reach a boundary called the event horizon. And once you cross the event horizon, well, you're past the point of no return. Its pull is just too strong. Like I said, even light can't escape. And if you fell in feet first, you'd actually be stretched and squeezed simultaneously by the extreme gravity and pressure. The official term of what would happen to you is called spaghettification. Sadly, it's got nothing to do with meatballs or a nice bolognese sauce. The scary thing, of course, is that black holes are constantly growing bigger and bigger and bigger by swallowing more and more matter. And now, it looks like Earth and all of humanity is on the menu. Oh, and one last thing about black holes. Like many other objects in our universe,
they have angular momentum. In other words, they spin and they have a charge associated with them. These are properties that need to sync up appropriately with the mass of the black hole in order to keep it in business. Just like if you were running a marathon, your body temperature and your blood pressure must stay in the right zone so that you can keep running. If you overheat, you might faint and fall over. Keep this in mind as it might play an essential role in taking down our black hole. Right, now that you've got a handle on what we're dealing with, well, it's time for a new attack. Oh yeah, we know we can't defeat this sucker by simple tricks like nukes. No, we've got to come up with something better. So we're going to do something pretty crazy. Let's try making our own black hole and see if it can defeat the one coming after us. But how do we do this? Well, the first step is making our black hole out of antimatter. Antimatter is just like matter, but with all the opposite properties. It's like the arch nemesis of a black hole. Of course, there's the small problem of actually making a whole lot of antimatter. But no worries, we have the technology to pull this off. All you have to do is accelerate a bunch of protons until they're nearly at the speed of light, and then you fire them into a material like iridium. This collision knocks out some of the fast-moving antiprotons, and the antiprotons are then slowed down and focused to help create antimatter. Oh, and we'd probably need this antiproton gizmo floating in space to create an antimatter black hole at the right coordinates. Definitely a little tricky to pull off. So, what's going to happen when we crash our antimatter black hole into the regular black hole? Well, once these two forces crash, there'd be a mega explosion of pure energy. But unfortunately, it doesn't work as intended. The energy from our antimatter just gets vacuumed up by the regular black hole, and it's now even bigger. Okay, this is not looking good, and the black hole is getting closer and closer and bigger, and we're running out of time. We've got to try something else. Since the black hole is getting bigger from us feeding it, well, maybe we could just starve it. What if we figured out a way to stop it from eating anything else? Well, that wouldn't work either, because the original mass of the black hole would still exist. But what if you tried the opposite? What if, instead of starving the black hole, you fed it with something? Something that's constantly throwing stuff out. But what could that be? My mom? Maybe the answer is a white hole. White holes function in ways opposite to black holes. The two of them are like yin and yang. If nothing can get out of a black hole, well, nothing can get into a white hole. If we threw a white hole at a black hole, the two might just annihilate each other, but they wouldn't disappear. There'd be a big burst of energy and a ton of gamma radiation. You'd want to steer clear of that zone. That radiation will give you cancer. Well, actually, you'd get such a massive dose that you'd probably just die instantly. Besides this, the only problem, well, we don't actually have a white hole, and we don't know how to make one either. Okay, so that strategy's a bust, but we're not gonna let that stop us. We will stop the black hole. This sounds a little crazy, but what if we built a time machine? One that could go back in time and take a black hole out. All we need is a wormhole to connect the black hole with its past. As we go back in time, the black hole has to spit out the mass it's taken in, making it a white hole. And if we traveled back far enough, we could reach the point just before the hole was born and blast it with nukes or lasers or whatever we have on hand. This idea works in theory, but we don't have a time machine or a wormhole. Let's try something a bit more realistic. All right, I got another idea. Maybe we can make a bomb that explodes spectacularly fast. I mean, faster than the speed of light. We need the speed because, remember, even light can't escape a black hole. So we'd need an explosion with escape velocity faster than the speed of light to blast out of there. If we did this, it might blow the black hole apart. The only hitch is we don't have a bomb that explodes that fast yet. So what else could we do? Okay, well, maybe you could deform this black hole. Target a specific part of it. Something like that might kill it. Well, guess what? We've got 4 different deformation options. How about attacking what lies at the heart of a black hole? That is, its density. If we stretched it out and took away its density, well, that would spell the end. But it can only be stretched if it has a finite size, and science isn't sure if black holes do or don't. The problem is, we're not 100% sure about the exact nature of what's inside the black hole. Is it a super dense, stretchable object? Or region where space-time curves, which would not be stretchable? Well, we don't know for sure because nobody's made it past the event horizon. Remember the spaghettification thing? But even without that knowledge, there's a second way you can destroy a black hole, and that's by destroying the event horizon. Without the event horizon, well, frankly, there's nothing for objects to fall into. One way to destroy the event horizon would be to poke a hole in it. If we just puncture the boundary at the event horizon, maybe the mass of the black hole would start to drain out. And with no mass, the black hole would no longer exist. But there's a third, more sophisticated way to deform the black hole, and it's got to do with some of the forces keeping the black hole going. Remember I told you that in order for the black hole to exist, the rate at which it spins and the electrical charge of the black hole have to stay within certain parameters? Remember that? Yeah, like when you turn your car around a corner, it needs a certain acceleration to make it around the corner safely. Overdo it and you might get into some trouble. Well, we want to destroy the black hole, so we're going to mess with these parameters. What if we increased the spin and amped up the charge of the black hole so much that its equilibrium broke down? This could be the final answer to destroying our black hole. Or we end up destroying the universe. So let's try something else. Now, could we just slow the spin of the black hole? Sure, we can extract energy from the black hole by dropping things into the event horizon. This will make the black hole rotate more slowly. If we did it enough, we could even make it stop spinning entirely. Now, this might slow it down, but it won't make it completely disappear. Okay, so there is one last option, and it's all about patience. See, black holes can destroy themselves over very, very long periods of time, and it's because of a weird process that's going on in the background. According to quantum theory, everywhere around us, pairs of particles are popping up, a particle and an antiparticle. When these crash together, they destroy each other. But in the case of our black hole, one particle might go into the hole and the other particle might escape into space. As this happens over time, the black hole becomes a teeny tiny bit smaller. And if we wait a few trillion years, the entire black hole will dissipate this way. You know, they say ignoring your problems doesn't usually solve them, but in this case, it will, after a few trillion years. So, can we destroy a black hole? No, not really. And even if we could, I'm fresh out of new ideas. So if you have any theories of your own, head on over to our Patreon, where you can join a private Discord to chat with us. Maybe you can help us solve the problem. But let's be real, a force this strong is virtually impossible to get rid of. Luckily, the chances of a black hole coming for Earth are just as impossible.
Black holes are dark, matter-devouring balls of gravity. Most of them are so far away that we don't need to worry about them, but not this one. Meet Gaia BH1. This enormous black hole sits right outside our solar system. More specifically, 1,600 light years away from us. Now, that might sound like a huge distance, but it's way closer than any other black hole on record. What's worse, we didn't even know about it until now. Despite Gaia BH1 being 10 times more massive than our Sun, we couldn't see it. Scientists usually discover these monstrosities by spotting the gas that a black hole feeds on. These hungry giants are called feeding black holes. Only Gaia BH1 isn't anything like that. This black hole is dormant. It hides in the darkness, patiently waiting for the galaxy to throw it some cosmic matter to feast on. But there's one thing that gave away Gaia's presence. You see, most star systems in the universe are binary. That means they have not one, but two stars orbiting each other. Our black hole neighbor is also part of a binary star system, except instead of two stars, this system has one star and one black hole. Yeah, Gaia BH1 was disguising itself as a star. But even though this monstrosity doesn't feed on any gas or matter yet, it still couldn't help but jiggle its star counterpart a little. Yeah, good try, Gaia, but we still caught you. Out there in space, there are black holes a lot scarier than Gaia BH1. And some are so bizarre that they shouldn't even exist. A team of scientists discovered an unbelievable black hole and gave it the melodic name LB1. The weird thing about this black hole is that it's just too massive to be true. Okay, let's get some facts straight. We know of two types of black holes. Stellar black holes are what massive stars become when they die. They're everywhere in the universe. Even in our Milky Way galaxy, there could be as many as 1 billion of them lurking around. These beasts can be between 10 and 24 times as massive as our Sun. The other type of black holes are supermassive ones. These enormities sit at the center of almost every galaxy, including our own. We don't really know how they form, but we do know that they're unimaginably gigantic, billions of times more massive than our Sun. But LB1 doesn't fit either of these types. At 70 solar masses, it's too enormous to be a stellar black hole, yet it's too tiny to be a supermassive one. Scientists were scratching their heads trying to explain this phenomenon. Some theorized that it might not be a single black hole, but two black holes orbiting each other. Others guessed that LB1 was born of a gigantic star that was still in the middle of becoming a black hole. Well, the answer was simpler than we thought. LB1 isn't a black hole at all. It's an optical illusion caused by two rare stars orbiting each other. It's a unique star system to stargaze. But when scientists said they found an improbable black hole, well, they were wrong. But please, how could you blame them? It's pretty hard to study an object 15,000 light years away. Mistakes happen. The good news is that LB1 didn't upend our understanding of black holes after all. Now, that doesn't mean that black holes can't blow your mind. Remember the one at the center of the Milky Way? Yeah, it's called Sagittarius A star, and it's as massive as 4.5 million suns. But there's always a bigger fish in the universe. Sagittarius A star might be the most massive monster lurking in our galaxy, but it's not even close to some of the really big players out there, like Ton 618. This black hole is devouring matter 10 billion light years away from us. It's as bright as 140 trillion suns. So bright that it outshines its own galaxy. And its mass? Yeah, 66 billion times that of our Sun. Yeah, that's right, 66 billion. Ton 618 is horrifyingly big. When scientists discovered it, they began to wonder if even more massive black holes were possible. Of course, the name supermassive wouldn't do bigger black holes any justice, so astronomers came up with a cool name for them too. Stupendously large black holes, or slabs. Yeah, and then they found one. Move over, Ton 618, there's a new gargantuan black hole in town. This stupendously large monstrosity sits at the center of Phoenix A galaxy, around 8.5 billion light years away from us. It's almost impossible to imagine how enormous this thing is. Scientists think it has a mass of 100 billion suns. That's more massive than some galaxies out there. And it won't stop growing. The event horizon of this black hole at the center of Phoenix A is unimaginably huge too. It has a diameter of about 100 times the distance between the Sun and Pluto. If you jumped on a SpaceX Starship and tried to fly across this black hole, it would take you 2,500 years to complete that journey. Yeah, we're lucky that this monstrous slab is so far away from us that we don't have to worry about it swallowing our solar system whole. But there are two more supermassive black holes very close to Earth. And they're on a collision course with each other. Okay, when I say very close to Earth, I mean 500 million light years away from us, but still closer than a lot of the other scary things out there. Seriously though, we don't know what exactly happens when two supermassive black holes collide. We've never observed a full merger of supermassive giants. Scientists think that they'll dance around each other for about 200 million years before finally becoming one. But this would be a violent marriage. As the black holes spiral together, they'll send enormous gravitational waves through space. Waves so big that we'll be able to detect them from our planetary neighborhood. But that's not the scary part. Mergers like that happen all the time, and right now, the Milky Way is on a collision course with the Andromeda Galaxy. When our two galaxies become one, what will happen to the supermassive black holes at their centers? Will they merge too? Would an event like this tear everything in its vicinity to shreds? Yeah, I bet that's what keeps astronomers up at night. A black hole is a celestial whirlpool of gravitational death. Things can go in, but they can't get out. But it turns out that one of the most powerful things in the universe could have a mysterious twin. A white hole. Yeah, this beast isn't exactly like a black hole. Black holes are incredibly dense objects that squeeze all the matter they ingest into an infinitely small point at their center, a singularity. Most black holes are remnants of massive collapsed stars, so they have a lot of mass condensed into that point. And a lot of mass means a lot of gravity. Every black hole has an event horizon. This is the boundary surrounding them that marks the point of no return. To escape from the event horizon, you'd need to be able to travel faster than the speed of light. White holes are the opposite. In the same way that nothing can leave a black hole, nothing can enter a white one. That's why scientists theorize that white holes might be the other side of a black hole. Rather than consuming matter, a white hole constantly ejects it into the universe. If not back into our universe, it could be a gateway to another. Now, while we've observed and even captured an image of a black hole, we've never seen a trace of one of its white twins. But scientists may have finally found the evidence they've been looking for. Mysterious gamma rays showing up where they shouldn't be. Gamma ray bursts are short-lived bursts of gamma ray light that last from a fraction of a second to a few minutes. And in this short time, they eject as much energy as our sun does over its entire lifetime. Gamma ray bursts are the most energetic events in the universe. They could be hundreds of times brighter than a supernova. and they happen when a black hole is born. If you traveled across the universe to catch a glimpse of this theoretical white hole, what you'd find would look like a black hole. A dark emptiness, a ring of dust and gas separated by an event horizon. But you wouldn't slide into the center of the singularity. No, instead, things would get rough. Your spaceship would be blasted by intense gamma rays, destroying it and everything inside. Now, even if you could survive that with the help of super advanced gamma protective technology that doesn't exist yet, you'd still never be able to enter the event horizon of this white hole. It would be like immense air resistance back here on Earth. The ejected radiation would constantly slow you down. Add to that the challenge of moving through space-time that's being warped around you, and it would almost be like you were traveling uphill with an extreme wind blowing you away. You'd need more energy to overcome this resistance and push forward. And the closer to the white hole you get, the more energy you'd require. There would come a point where you'd need more energy than there is in the entire universe. But there might be another way in. If a white hole truly is the backside of a black hole, then traveling into its singularity would be like going through a black hole in reverse. But now, not only would you be competing against the powerful forces of gamma radiation, but you'd also need to overcome the impossibly powerful forces of gravity working against you. Oh, and you'd need to travel faster than the speed of light. Of course, that's impossible. Nothing can travel faster than light, but you might be able to get to your destination by jumping into a black hole first. Scientists think that there might be a wormhole connecting the white hole to its black hole companion. This could be your only way in. Except this passage would be extremely unstable. The entire thing could collapse unpredictably at any moment. I doubt you'd want to be inside when that goes down. Don't say I didn't warn you. If you were brave enough to jump into a black hole, well, you'd have to pass its event horizon. Once you were inside, you'd see another energetic burst of bright light. After this, the black hole would seem to expand all around you, surrounded by a ring of light. You'd be feeling pretty disoriented by now, and it might almost appear as if you were free-falling back through the black hole. This wouldn't be the case. This is just an optical illusion known as relativistic beaming. And of course, this wouldn't be the only extreme effect you'd experience. You'd still need to do the impossible and somehow break the cosmic speed record. Traveling faster than the speed of light, you'd be overcoming the most extreme forces of gravity pulling at you from behind. And because of that, your entire body would be stretched out very thin. This would be reverse spaghettification. And finally, the disorienting effects of the relativistic beaming would make it appear to shrink ahead of you, like you're getting further and further away. But eventually, you'd overcome all that gravity and blast your way out of the event horizon. And now, you'd be spewed out the other side of the black hole into a completely different part of our universe. Or maybe not even in our universe at all. Yeah, come on, you just traveled through a black hole and then a white hole. Anything's possible. 13.8 billion years ago, all the matter and radiation that makes up our universe emerged out of a singularity. Maybe you just traveled through the black hole that created our universe. It sounds like you've got another epic journey of discovery ahead of you. Dark, mysterious, and consuming everything around them. Black holes will rip apart anything that passes their event horizon, but could there be more? What would happen if you fell into one of these monstrosities? How could you possibly travel through the black hole itself? And if you emerged out the other side, where would you end up? This is What If, and here's what would happen if you traveled through a black hole. Black holes aren't that much different than any other object in the universe that has mass, except that they are really, really dense. At their center is a singularity, basically an infinitely small point where all their matter is compressed. The more matter that's packed into a black hole's singularity, the stronger its gravitational pull. Considering that some black holes are the remnants of stars with more than 10 times the mass of our Sun, they have a lot of gravity. And every black hole has an event horizon. This is the point of no return. Once you cross that, there's no way back out. And unless you traveled as fast as the speed of light, you wouldn't be able to escape it. We don't know exactly what happens to something beyond the event horizon because once something is past it, there's no way of sending a message back. But odds are, gravity would rip you apart, atom by atom. Unless there was some other way out? If you were lucky enough, you wouldn't just be venturing into the unknown depths of any normal black hole. You'd be crossing the event horizon of a charged black hole, equipped with a one-way wormhole that connects the black hole with a white hole. Now, white holes are strange. Instead of consuming all matter in their path like black holes do, they only spit stuff back out into space, and nothing is able to enter a white hole. Except you wouldn't just cross the event horizon and end up spat out on the other side. You'd better be ready for one of the most mind-blowing experiences the universe has to offer. As you were preparing for the trip of a lifetime on the outskirts of the black hole, you'd see stars twisted around a perfect circle of darkness. It's too bad there wouldn't be much time to enjoy the view. This gravitational monster would start pulling you toward it, faster and faster. The gravitational force of a black hole is unbelievably strong. It's so strong that it would turn you into spaghetti. If you were falling feet first, your legs would experience a significantly more intense gravitational pull than your head. Your body would get stretched into oblivion. Well, we don't want that to happen to you just yet, so let's say you'd fall into a wormhole just before the black hole ripped you apart. And don't forget, you'd be traveling through not just any black hole, but a charged one. Not only would there be a wormhole lurking inside it, but this black hole would also have 2 event horizons. But as you were crossing the space between the 2 points of no return, you'd likely not realize what's happened. You'd be in free fall, and as you'd fall deeper, you'd find the black circle in front of you appear to grow bigger and bigger. If the black hole was as large as the one at the center of the Milky Way, this would take about 20 seconds. And with all the painful spaghettification you'd be experiencing, those 20 seconds would seem to last for an eternity. But once you approached the inner horizon, the black hole would appear to stop expanding. And then, surprisingly, it would seem to shrink, almost like you started falling away from it. For a moment, you might think you've already cleared it, but this wouldn't be the case. It's only an optical illusion. You're still in free fall. This trick on the eyes is caused by something known as relativistic beaming. All it would do is squeeze what you see in front of you to make it appear as if the black hole was shrinking. And the light from the rest of the universe outside the black hole would appear brighter around its edges. But as you finally pass the inner horizon, that wouldn't be the only light you'd see. At this point, you'd be overwhelmed by an energetic bright burst. and not just any old boring burst of light. You'd be witnessing a reflection of the entire history of our universe seen through the singularity of the black hole. Within the inner event horizon, you'd now be careening through the wormhole connecting you to the white hole. But if you thought being stretched was bad enough, think again. You'd be trapped in an extremely unstable phenomenon. The enormous gravitational forces of the black hole would threaten to obliterate the wormhole any second. As you were crossing the second event horizon, you'd see another energetic burst of light, but this time, instead of seeing a reflection of the universe's entire past, you'd see its future. Keep in mind, this wouldn't be the future of the universe as you know it. And you wouldn't just be passing through the singularity of the black hole and out the other side. No, you'd be about to get spewed out by a white hole into a completely different universe from your own. Finally, you'd be out of the white hole. As the distance between you and it increased, you'd also see all the light from our current universe that came along for the ride with you. And hey, congratulations! You'd be the first person to explore an entirely new universe. There could be so many incredible things for you to discover. You could find yourself in a parallel universe. Another version of you could be living the best life you've always imagined for yourself. But hey, you just traveled through a black hole, so how much better could it get? Unfortunately, the news might not all be good. You could be stuck having to follow completely different laws of physics from the ones we know. Gravity could be weaker, stronger, or even non-existent. And the building blocks of matter could be made from dark matter. Or they could be made up of antimatter. In which case, your mind-blowing joyride would be about to meet a deadly end. Antimatter and ordinary matter, like what you're made of, would annihilate each other upon contact. And worst of all, you wouldn't be able to just turn around and return home. Remember, you couldn't jump back into the white hole because it doesn't suck anything into it. That was a one-way trip. Sorry. Well, I hope it was fun while it lasted.
Black holes are dense and scary. They suck up everything in their way. Their gravity is so strong it bends light and
Warps time.
But what if I told you we might have been wrong about these cosmic vacuum cleaners? Well, for one, they're not vacuum cleaners at all. Black holes don't go around gobbling up everything in their vicinity. You'd have to cross a black hole's event horizon to get sucked into one. The event horizon is the area around a black hole where its gravity is so strong that you'd have to move at the speed of light to escape it. And moving that fast is simply impossible, at least according to Einstein. That's why there's no escape after you cross this line. The extreme gravity would pull you in, and then you'd disappear into the blackness of a black hole. Forever. But as long as you stayed on the safe side of the event horizon, you'd be completely fine. Now, if you had a bad day and ended up sucked into a black hole, it might not be as violent as you think. Despite a black hole's unimaginably massive gravity, it wouldn't instantly crush you like a can of soda. No, you'd experience something that scientists call spaghettification. It's when a black hole stretches you into the shape of, spaghetti. If you were approaching a black hole feet first, your legs would get long and skinny before your head started to change shape. Once you crossed the event horizon, the stretching you'd experience would be extreme and painful. The black hole wouldn't crush you. Instead, it would rip your molecules apart. This whole spaghettification process would only take a few seconds, maybe a few minutes tops.
Sorry, did I say it wouldn't be violent? Yeah, I take that back. This would really hurt. But the good news is you could still make a comeback. Just not in the same form as you entered the black hole. Yeah, you may have heard that nothing escapes a black hole, but that isn't exactly true. All thanks to Hawking radiation. Turns out, black holes have an interesting quantum phenomenon going on. At the very edge of a black hole's event horizon, particles are constantly forming. Some of them fall back into the black hole, but others escape this monstrosity's gravity in the form of radiation. Hawking radiation, to be specific. Over time, so many particles escape a black hole's event horizon that the black hole disappears entirely, like it never even existed. But it takes an incredibly long time for a black hole to evaporate like this. And unfortunately, you wouldn't be able to reassemble yourself from all those emitted particles. So I really wouldn't recommend jumping into a black hole. Especially not into a supermassive black hole in the middle of our galaxy. One good thing that can come from getting close to a black hole is that you could, hypothetically, harvest its radiation and use it to power things back on Earth. Of course, we're nowhere near that kind of technology, but we have other sources to produce clean, renewable energy, like nuclear fission. I know, when you think of green energy, all that comes to mind is solar panels and wind turbines. Well, that's why I wanted to tell you about nuclear energy. It's zero emission, meaning it doesn't generate harmful byproducts like fossil fuels. It uses way less land than solar or wind farms to produce massive amounts of carbon-free power. And it's super efficient when it comes to waste. Win, win, win. As we aim for a cleaner future, nuclear energy can massively help us reach the goal of 100% clean electricity by 2035. And a net zero emissions economy by 2050. Now, that sounds like the kind of future I'd be looking forward to. You? Well, at least it's a lot better than falling into a black hole. You see, there are different types of black holes. The most common ones are stellar black holes. They are the remnants of stars at least 20 times more massive than our sun. And because they're so dense, well, their event horizons can be several kilometers in diameter. Supermassive black holes are monstrous, unimaginably big. The most massive black hole scientists have spotted so far is located in the middle of Phoenix A galaxy. It's got a mass of 100 billion suns. Yeah, billion with a B. At this point, it's not just a supermassive black hole, it's a stupendously large black hole, or slab. Until recently, scientists thought the biggest supermassive giant was Ton 618, a black hole with 66 billion solar masses. But there's so much of the cosmos we haven't discovered yet, and maybe supermassive black holes can be much, much more massive than we could ever imagine. Scientists still don't know exactly how these cosmic monstrosities formed. And we've got no idea what happens when two of them collide, but it sure wouldn't be pretty for anything caught in between them. But at least we can still observe them to find out more. A black hole's gravity is so intense that even light can't escape it, but that doesn't mean they're the stealthy ninjas of the cosmos. They're very much visible, just not in the way you might think. Because their gravitational pull affects stars around them, astronomers can detect their gravitational effects. They can also see X-rays when something big falls into a black hole. That's because when matter is pulled to the point of no return, it heats up to intense temperatures. But the most mysterious thing about black holes is what lies on the other side. There are theories that black holes can be gateways to other universes. A black hole might be connected to another point in space and time through what's known as an Einstein-Rosen bridge. It's a type of wormhole, and a very unstable one. Now, scientists haven't found proof of that yet, but that doesn't mean it's not possible. What if we could use black holes as cosmic subways? Where could they take us? Could it be another reality? Another time? Well, while all of this is fun to think about, there's one big problem. Einstein-Rosen bridges are incredibly unstable. They could collapse on you at any moment, trapping you inside a black hole before you could reach your mysterious destination. And even if we were lucky enough to pass through that bridge before it collapsed, there's still no way you could survive it. The intense gravity and radiation would likely destroy you long before you popped out on the other side. Maybe one day we'll learn to travel through black holes, but for now, it's best to stick to exploring our own solar system. Hey, why not visit Titan, one of Saturn's most beautiful moons? Well, that's a story for another What If. The universe, so dark, mysterious, and unimaginable.